Hello students, welcome back. Welcome to the third session of the chapter Solutions. In the previous session, we have discussed about the types of solutions and in detail we have also discussed about the aqueous solutions. In the today's session, as I already told you people in the previous session, we will be discussing mole concept. As such, mole concept is not a new concept for you people as you have already studied it in grade 11. So you might be having a doubt if you have already studied it in grade 11. So what is the need to do it here? We need to do mole concept to understand concentration terms better. Okay, as the chapter name tells us, it is solutions. When we talk about solutions in chemistry, we need to talk about the concentration of the solutions. So before we move to the very important topic of the chapter, concentration of solutions, I want to quickly brief you people about the mole concept so that your understanding for concentration terms becomes very easy. Okay, when I talk about mole concept, the main important term that comes to our mind is mole. What is a mole? To hear it might sound very, as a very difficult term, but as such, mole is a very easy term, like a very fancy term which we use in chemistry. Well, before we understand mole, let us come to mole by understanding a few terms in our daily life. For example, if you go to a grocery store, you don't ask, what do you ask there? You don't ask like, give me 15,000, grains of rice. You don't ask like that, right? If you ask like that, he will be annoyed. Like, now how can I count like 15,000 grains and I can give you? So what do? You don't use the term there. You have a quantity term to use there. You say that give me 1 kg of rice, give me 2 kgs of rice. Okay, so the shopkeeper has a clear understanding that you're talking about 1 kg of rice, which clearly indicates you're talking about 1000 grams of rice. So we in daily life use certain terms, okay, for to make our understanding of quantities very easy. Okay, in the similar way, let us use a very common term which we use in our daily life. Okay, 1 dozen of bananas. You need not go to the shopkeeper and tell him that I need 36 bananas. Okay, no, we use a very simple term. You say I need 3 dozens of bananas. Because in our daily life, we are very much habituated to the term called dozen, which is equal to 12. Okay, fine. Okay, all this if you feel are like very boring examples. Now, when I say Virat Kohli has hit a century, so I need not tell you very specifically that Virat Kohli has hit 100 runs, because you people have this term in your mind. Century means 100. So whenever I say century, you will immediately relate that he has scored 100 runs in particular match. Okay, so we have certain terms in our mind which are like fixed quantities in our brain. For example, if I can quote one more example. A particular organization is celebrating its silver jubilee celebrations. When I say silver jubilee, I need not specify you. It has completed its 25 years, so they are doing silver jubilee celebrations. Okay, a particular married couple is celebrating golden jubilee. Then it is very obvious that they are celebrating their 50 years of marriage. Okay, like this, in our daily life, we have many terms which we use as standard to mention few quantities or to mention certain span of years. Now, when we come to chemistry, because all our focus is now to understand in chemistry what is the importance of the term mole. Now, in chemistry, when we talk, we have particles, we have atoms, we have electrons, we have protons, we have neutrons. All these particles are very small in size, and they are in you like they are millions in numbers. Now if I keep on saying like there are 3 electrons, there are there are 50,000 particles. Okay, there are some 1.5 million particles. It is very difficult for me to always use these terms, because we are talking about a very big number here. Okay, we are talking a very big number here, where it is always difficult for me to keep on counting. If I want to say, I can't keep on saying like 5.5 million particles of this particular atom. So it always becomes very difficult for me to use those terms, because one might use a term called million, other might use some different term to tell the quantity. So there is lot of confusion among people, or there is lot of confusion among the, among the field of chemistry, if we start using different terms to tell these particles in chemistry or to address these particles in chemistry. So we thought, okay, so there was a thought that why don't we fix a term in chemistry which tells us about certain number of particles. With that thought, okay, they have framed a word called mole. Now if I say 1 kg, you get in mind it is 1000 grams. If I say 1 dozen, in your mind you get 12. In the same way, in chemistry, if we say 1 mole, okay, if we say 1 mole is equal to 6.022 into 10 to the power of 23 entities. Okay, any, see, if I, for example, if I ask you, okay, count 1 mole of apples, then you will start doing this. How many apples should you accumulate to say that 1 mole of apples? 6.022 into 10 to the power of 23 entities comprise 1 mole. Now what can these entities be? These entities can be your atoms, these entities can be your molecules, these entities can be your ions. Or basically you can say, in place of entity, if you are feeling the word is complicated, you can use the word particles. Okay, 6.022 into 10 to the power of 23 particles will constitute 1 mole. Okay, if I say 1 mole of bananas, then how many bananas am I talking about? I am talking about 6.022 into 10 to the power of 23 bananas. So this is a very simple understanding of what is a mole. Okay, this gives a very clear understanding. Now, let us try to understand this concept like little mathematically. Okay, little mathematically. Okay, for example, if I say, okay, 24 bananas. Then okay, for example, if someone says 24 bananas, you try to tell them, we don't usually use use this term when we go to a market. Okay, so we will try to convert this 24 bananas in terms of dozen. Okay, now if I have to convert this 24 bananas in terms of dozen, what should I do? Okay, I should divide it with a reference number. Yes, what should be that reference number? I know 1 dozen is equal to 12. Okay, now if I have to find out 24 bananas is equal to how many dozens, I will obviously divide this 24 with my reference number. What is my reference number here? 12. Okay, so 24 bananas refers to how many dozens? 2 dozens. So here, how am I trying to get to the number of dozens? Whatever number was there with me, I have divided that number with the reference number. Then I got my number of dozens of bananas, which infers to 24 bananas. Okay, let us slowly take this concept. Okay, let us slowly take this concept to number of moles. Now, in the same way, I will do one thing here. If I say 12.044 into 10 to the power of 46 bananas. Okay, now you feel it is very difficult for me to to say this big number. So what should I do? Instead of saying 12.044 into 10 to the power of 46 bananas, I will try to convert it into a simpler term. Okay, for me 24 converting into dozen was fine. But now for me, if I am talking about 12.044 into 10 to the power of 46 bananas, now I am asking you, I want to talk about bananas in terms of moles. Okay, so I'm asking you, I'm asking you people, 12.044 into 10 to the power of 46 bananas refers to how many moles? The process is very simple. What did I do here? I have divided it with the reference number. The reference number for 1 dozen was 12. So what will be your reference number for 12.044 into 10 to the power of 46 bananas? To convert it into moles, what is the reference number of mole for me here? 1 mole is equal to 6.022 into 10 to the power of 23. So I'll just divide this number of bananas with the reference number. So just divide it with 6.022 into 10 to the power of 23. So if I divide it with my reference number, I will get the I will get the number of moles of bananas. So what am I trying to do here? I am trying to convert the larger number into my required simplified term. Either it might be dozen or it might be mole by dividing it with the reference number. Then it is great. So we are trying to simplify the things instead of using bigger numbers and the complicated numbers. We are trying to simplify it into a simpler quantity. Okay. Now we have done this, so you got a basic idea that if I have to find the number of moles, so you people will feel happy. Now almost we have come closer to get the first formula to get the number of moles. What did I do here to get the number of moles? I have divided the given number of particles or the given number of bananas, or in chemistry the given number of particles with the reference number. So can I convert the same thing, or shall I use the same thing for chemistry? Can I frame the first formula of number of moles by using all this concept? Let's do it. There are three major formulas to calculate number of moles. Moles. In that the first one is calculation of moles using the number of particles. Let's see the first formula and how did we come to the first formula based on this. So before going to the formula part of number of moles, let's quickly write what we have studied. 1 mole is equal to 6.022 into 10 to the power of 23, which is equal to Na. So 1 mole is represented by Na, capital N and capital A, which is your Avogadro's number. So what is Avogadro's number? 6.022 into 10 to the power of 23 is your Avogadro's number. So this is how 1 mole is equal to 6.022 into 10 to the power of 23, which is equal to Na, which is your Avogadro's number. Now let us talk about the first formula for the number of moles. Moles in terms of number. Moles in terms of number. Now this we have already understood. How do we get moles in terms of numbers? So number of moles is equal to how many number of particles are given to you? Number of particles given divided by how many particles? Our reference number, which is 1 mole. 1 mole is how many particles? 6.022 to 10 to the power of 23, which is equal to Na. So number of moles is equal to number of particles given divided by Avogadro's number. We'll still simplify it. Number of moles is represented by small n. Number of particles is represented by capital N divided by Avogadro's number. So this is your first formula to calculate the number of moles. Number of moles is equal to number of particles given by Avogadro's number. As I told previously, here particles can be what? Particles can be anything. They can be atoms, they can be molecules, they can be ions, etc. Like this you can calculate. Let us take a small example. If I say 3.022 into 10 to the power of 10 to the power of 46 neutrons. So how many number of particles are given to me? 3.022 into 10 to the power of 46 neutrons are the particles which I am considering here. Now it is very difficult for me to always say 3.022 into 10 to the power of 46 neutrons. So what did I tell you? Now when we feel the number is bigger, let us try to convert into a simpler quantity. In chemistry, what is a simpler quantity for us? number of moles. Now how should I convert this into the number of moles? By dividing it with the reference number. What is the reference number? You know, it is your Avogadro's number. So how will I convert this number of particles into number of moles? Number of moles is equal to given number of particles divided by Avogadro's number of particles, which is equal to 6.022 into 10 to the power of 46 divided by 6.022 into 10 to the power of 23. If you do the division here, okay, 1 time, 2 times, so this goes 2 times. So how much are you getting here? 0.5 into 10 to the power of 2. So it is basically 0.5 into 100. Am I clear? Okay, 0.5 into 100. So how much does it come to? It comes to your 50. Okay, so how many moles these many number of neutrons refer to? It refers to 50 moles. So this is a simpler way. How do you convert the number of particles into number of moles for your simpler understanding? I have just taken a random example. So I just want you people to understand how do you convert the number of particles into number of moles. So this gives you a very clear understanding of how do you convert the particles into moles, that is by dividing it with the reference number. So anywhere from now in chemistry, if you see number of particles, if they ask you to convert into moles, how are you going to do it? You are going to divide the given number of particles with the reference number. Okay, hope this concept is clear to you. Now we'll go to the next formula to calculate the number of moles, which is moles in terms of mass. There I will be teaching you a very important concept of molar mass. Now let's understand the second formula to calculate the number of moles. Number of moles is equal to given mass divided by molar mass. Okay, given mass divided by molar mass. Okay, we know that the given mass will be given in the question, like 5 grams of sodium, okay, 2 grams of magnesium, that will be given in the question. But what about the molar mass? What about the molar mass of magnesium? What about the molar mass of neon? What about the molar mass of sodium? What exactly is molar mass? First, let's understand what exactly is molar mass. Then obviously you can apply it in the formula. Okay. Now, as the name suggests, molar mass, it is the mass of 1 mole of, okay, it should be the mass of 1 mole, okay, 1 mole of what? 1 mole of atoms or molecules. Am I right? It is the mass of 1 mole of atoms or molecules, or as such any particles you are taking over there. Okay, but the condition is the quantity should be 1. Am I right? So molar mass is the mass of 1 mole of atoms or molecules or whatever particles you are taking. Okay, when I say 1 mole of particles, okay, I can also say it is the mass of 6.022 into 10 to the power of 23 particles. In the previous formula, we were talking in terms of particles. Now we are talking in terms of mass of them. Okay, so when I say molar mass, it is a mass of 6.022 into 10 to the power of 23 particles. Okay, let us take a small example to understand this. You people have should be knowing the molar masses in your grade 11. If I say what is molar mass of hydro, okay, if I say what is molar mass of sodium, you know it is 23. If I say what is molar mass of magnesium, you say it is 24. Okay, am I right? Yes, so this basic understanding you already have in your grade 10 and 11. Now we are just trying to understand how to apply those things to get the number of moles. Now if I say, okay, we already know molar mass of hydrogen atom is equal to 1 gram per mole. Okay, so what is the mass of 1 mole? Okay, what is the molar mass of hydrogen atom? It is 1 gram per mole. What does it indicate? When I say molar mass of hydrogen atom is 1 gram per mole, what does it indicate for us? It indicates that, okay, this 1 gram per mole, it is the mass of 6.022 into 10 to the power of 23 hydrogen atoms. Am I right? When I am saying molar mass of hydrogen atom is 1 gram per mole, here when I am saying molar mass of hydrogen, what am I talking about? I am talking about mass of 6.022 into 10 to the power of 23 hydrogen atoms. Mass is how much? 1 gram per mole. So whenever I am saying molar mass, we are talking about 6.022 into 20 to the power of 23 particles. Here, because hydrogen, I am talking about hydrogen atom. I am not talking about hydrogen molecule. So here, what is our entity here? Atom. So whenever I say molar mass of hydrogen atom, I am talking about mass of 6.022 into 10 to the power of 23 atoms of hydrogen. Let us take one more example. If I say molar mass of H2. Okay, if I say, because we people know hydrogen exists in nature in a molecular form. So when I say molar mass of H2 in molecular form is equal to 2 gram per mole. Okay, we all knew it. Okay, we all knew it. Like molar mass of H2 is 2 gram per mole. What should I understand from this? I should understand that 2 gram per mole, it is the mass of 6.022 into 10 to the power of 23 H2 molecules. Because here I am talking about the molecular form of hydrogen. Okay, what form of particles I am talking about? Molecules. So when I say molar mass of hydrogen is equal to 2 grams per mole, I am talking about mass of 6.022 into 10 to the power of 23 hydrogen molecules. So this is what you need to understand when I am talking about molar mass. If you want, let us take one more example. Okay, if I say molar mass of sodium is equal to 23 gram per mole. Here what do I infer to here? I infer to what is 23 gram per mole? It is the mass of 6.022 into 10 to the power of 23 atoms of sodium. Clear? Because here we are talking about the atomic atomic form of sodium. What is 23 gram per mole? If I am saying 23 gram per mole is the molar mass of sodium, what should immediately come into your mind? We are talking about mass of 6.022 into 10 to the power of 23 atoms of sodium. Okay. Ma'am, now what about the molar masses? You should be knowing the molar mass of at least the first 30 elements in the periodic table. Okay, from hydrogen to zinc. As a grade 12 child, you should be knowing the molar masses from hydrogen to zinc. Atomic number 1 to atomic number 30, you should be knowing. So please learn the molar masses of the first 30 elements in the periodic table, so that when you start doing the numericals in concentration terms, it will be very easy for you. For example, in the numerical, when you are doing a numerical in concentration term, you need to find the number of moles of NaOH. Then if you know the molar mass of sodium, oxygen, hydrogen individually, you can add them and you can get molar mass of sodium hydroxide. So as a grade 12 child, it is very important for you to remember the molar masses of all the first 30 elements of the periodic table. Okay, so this is our second formula to calculate the number of moles. Okay, you might be thinking, okay, no, ma'am has explained us, what is molar mass, but how to calculate number of moles by using molar mass and the given mass. Okay, let us see a small, one or two small example questions to understand how do you calculate number of moles by using this formula. So I have taken a simple question to make you people understand how to calculate number of moles in terms of mass. See this question, calculate number of moles of 8 grams of helium and 32 grams of oxygen. Let's start with the first one, 8 grams of helium. So in the question, he is talking about mass. So which formula of number of moles I will be using? The second formula which I told you just now. Because first formula is useful when they give you the number of particles. But here they have given you the mass. So let us use the formula where I can substitute mass. So number of moles is equal to given mass divided by molar mass. Okay. So what is the given mass of helium in the question? 8 grams divided by what is the molar mass of helium? I already told you should be knowing the molar masses of first 30 elements in the periodic table. So molar mass of helium is 2. So how many moles? 4 moles. So 8 grams of helium is in terms of grams. If I want to talk about 8 grams of helium in terms of moles, it is 4 moles. So 8 grams of helium refers to 4 moles. So what should be your answer? Calculate the number of moles. Your answer should be 4 moles of helium is your final answer. Let us come to the next bit here. 32 grams of oxygen. Oxygen is in molecular form. Okay, make a note of that. Okay, number of moles is equal to given mass divided by molar mass. So what is the given mass here? 32. What is the molar mass of oxygen? Single, okay, I am talking about molecular oxygen. Single oxygen molar mass is 16, but oxygen is in diatomic form here. So 16 plus 16, it is your 32. Okay, single oxygen molar mass is 16 because oxygen is in diatomic form. What is the molar mass of oxygen here? 32 gram per mole. Okay, so that is equal to 32. So which is equal to 1 mole. Clear? 1 mole of oxygen. So 32 grams of oxygen is equal to how many moles of oxygen? 1 mole of oxygen. So this is how we convert the number of grams into number of moles. Okay, if they give the mass of particular element or compound in the question, you can convert it into number of moles by dividing it with its molar mass. This is how you calculate the number of moles in terms of mass. Now we are done with the calculation of number of moles in terms of number of particles. Then we are done with the calculation of number of moles in terms of mass. Now let's come to the last one. How do you calculate number of moles in terms of volume? Now the last and the final way of the calculating the number of moles in terms of volume. Now when we talk about moles in terms of volume, this is applicable only for gases. Okay, so this is not applicable for liquids and solids. We usually apply this method of determining the number of moles for the gases. First, let's see the formula, then I'll explain you further. Number of moles is equal to given volume divided by volume occupied at STP. Okay. Now, the given volume of the particular gas, that will be there in the question. Then what about the volume occupied at STP? Now, I will go in little bit detail about this. When I say volume occupied at STP, any gas, like for example, you take oxygen gas. Now, when I take oxygen gas at STP, so before that, I'll give you a clarity on what is STP in chemistry. It is standard temperature and pressure. It talks about the standard temperature and pressure. What is the standard temperature we are talking about here? 273.15 Kelvin. The standard pressure we are talking about here is 1 atmosphere. So at STP, I am talking about oxygen at STP. Means what? Oxygen is there at a temperature of 273.15 Kelvin and at a pressure of 1 atmosphere. So any gas, not only oxygen, any gas, we take oxygen, nitrogen, helium, carbon dioxide, nitrogen dioxide, you talk about any gas at STP, any gas, I'll write it here, any gas at STP. What is STP? Standard temperature and pressure, 273.15 Kelvin of temperature and 1 atmosphere pressure. Any gas at STP occupies 22.4 liters. So any gas you take, how many liters of volume does it occupy? 22.4 liters. Okay, so any gas at STP will occupy how much? 22.4 liters. So okay, now we already have understood now how many liters does the gas occupy at STP? 22.4 liters. So let us quickly substitute it here. So number of moles is equal to given volume divided by 22.4 in liters. Clear? If you want to deal in ml, for example, if you want to deal in ml, then you can write the same formula as given volume, because if in the question the volume is given in the ml, and if you want to deal in ml, then you can just write given volume divided by 22,400 in ml. Okay, depending on the data given in the question, you can go for any of the formulas. If it is ml, go for this formula. If it is in liters, then you can go with this formula. Now let's quickly do an example question. It is a very simple concept. Okay, for example, calculate number of moles. Okay, calculate number of moles for liters of carbon dioxide. Okay, how do you calculate number of moles for 44.8 liters of carbon dioxide? We have our formula with us. Number of moles is equal to given volume divided by 22.4 liters. So what is the given volume? 44.8 liters divided by 22.4 liters, which is equal to how much? 2 liter also gets cancelled. So it is here 2 moles of CO2. So 44.8 liters of CO2 is equal to how many moles of CO2? 2 moles of CO2. Okay, this process is used only for gases. If they give the given volume in the question of that particular gas, you can easily calculate the number of moles of that gas by dividing the given volume with the volume occupied at STP, which is 22.4 liters. Okay, so this is the last and the final method of calculating moles in terms of volume. Very simple method. Very simple method. Just you have to remember the denominator number, which is 22.4 liters, which is the volume occupied by any gas at STP. Okay, so in this session, I have discussed it in brief about the mole concept, because you have already studied it in grade 11. I tried to cover the part which is needed for you people to understand the next topic, which is our concentration terms. Okay, so in the next session I'll be explaining you different concentration terms in the chapter solutions, because when we talk about solutions, every solution has a different concentration, and that is where the full understanding of chemistry of solutions lies. Okay, so hope you have understood all the 3 formulae which I have taught you to calculate the number of moles. First, moles in terms of mass, first moles in terms of particles, next moles in terms of mass, and then moles in terms of volume. I hope you are clear with all this concept which I have taught you. And now I'll see you in the next session with a very important concept, which is our concentration terms. Till then, see you. Bye.